Okay, so here we are in third video of the Trig. This is section 6.2 in the pink book that we're using. So today we're going to talk about pieces of triangles. So let's go back to Pythagorean theorem, if we remember. We talked about a squared plus b squared equals c squared. Okay. Just remember that. You may need to use that in your homework some tonight as far as finding sides of triangles. Also, if you will also remember that when you have a triangle, okay, and it doesn't matter if it's a right triangle or whatever, you have angles A, B, and C. All right. Maybe we ought to use different letters so we're not looking at the same. Let's do a triangle. We'll do angles X, Y, and Z. If you remember correctly, they will add up to 180. So these are just a couple of geometry skills that you will need for this lesson. So the whole point of this lesson is we're going to take triangles and solve them, find missing pieces, and whatnot. So we're going to use the sine, cosine, and tangent to find quite a bit of these. Also, if you remember your special triangles, we will need these as well. So this is 45, 45, 90. Okay, so 45 plus 45 plus 90 is 180. Our sides are 1, 1, and square root of 2. And we'll also have 30, 60, 90. So there's a 30, there's a 60, there's a 90. Opposite of 30 is 1, opposite of 60, square root of 3, and the hypotenuse is 2. So let's say I'm given a triangle. Now, these are just pieces that you need. We're going to do examples. So let's say I'm given a triangle that looks like this. It is a right triangle. I know that this angle right here is 60. Okay? And I have this as labeled H, and this is 72. And I want to know what H is. Okay, I want to find H. So if I am given this triangle and I need to find H, if it's a 60, right? So let's look at the pieces that we know. We have the adjacent to the 60 and the opposite of. So if I have the cosine of 60, that's going to equal. Right, what is the cosine of 60? It is 1 over 2, right? Okay. So the cosine of 60 is 1 over 2, and I have this cosine of 60 is 72 over h. What do I know about those fractions? Right? Cosine of 60, cosine of 60 are the same. I can set them equal to each other. And at this point, you should be able to, in your head, figure out what this means, right? If 1 is the same as 72, I have to go 2 times 72 to get h, all right? So h equals 144. So this uses ratios, it uses fractions, it uses just total portions to find the pieces that you need, all right? So part of your homework is just given a piece and finding it, all right? So another part of your homework is you're going to be given a triangle that has no pieces, okay? And you're going to actually use this triangle for a lot of your homework problems, okay? And it is this triangle is going to be labeled in such a way that you can use it for several problems, and each problem will give you different names for it. So on your homework tonight, I actually expect a lot of work. I expect to see these triangles drawn and work shown. So this triangle itself is going to be labeled like this, and this looks almost identical to the one that's in your homework. Okay, so the uppercase letters represent the angles, the lowercase letters represent the legs of the triangle. All right, oops, I messed up on that one. Okay. These are actually the opposite of the angle that they represent. So this one is A, and that one is C. So now we have a triangle. Homework's going to ask questions like this. It's going to say, if C equals 12, that's an uppercase C, by the way. If C equals, or lowercase c, sorry. If C equals 12, and the measure of angle C is 37, find the rest. find the rest. So we're going to go ahead and put these pieces in here. So if I know that this is 37, and I know that this is 12, okay? Right off the bat, I'm going to find my last angle, because I have, this is a 90-degree angle, right? So 37 plus 90, I'm going to subtract that from 180 to get what my third angle there, or angle A, is. So angle A is 53. So we're going to put this in here. All right, now we have all of the angles. We need to find the rest of the sides. And we can do this by using trig, okay, or by using the sine, cosine, and tangent. So I'm going to do this, and you could use whatever you want. Now this is where a lot of your work is going to be different from other people. You should all end up with the same answer, but the work may be different. So if I start out with knowing, okay, so I have this angle 37 here, and I have the side is 12, so I'm going to use this side. So since 12 is the opposite, I'm going to use the sine, because I want to find B and A. B, I'm going to have to use the tangent, and sine, I can use that. So we're going to go the sine of 37 equals 12 over B. All right, now I need to do some algebra and some figuring here, okay? So actually, I'm going to multiply by B. Okay, I'm not going to go through all this on the board, but you should be able to figure this out. You know your algebra well enough. Multiply by B and then divide by sine over 37. So I'm going to have B equals 12 over the sine of 37. And you can actually put this in your calculator. Please, 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 please make sure that it is in degree mode. If it is not in degree mode, you're going to get the answer wrong. All right. So I'm going to double check my calculator. Yep, I have it in degree mode. So if I go 12 divided by the sine of 37, I get 19.93, okay, for my side here. Now I can do this in a number of different ways to find the last angle, or to find the last side of A. All right, I have all my sides. I have angles. I could also use the A squared plus B squared equals C squared. That might actually be the easiest thing. If I have 12 squared plus A squared, that's what's missing, equals 19.93 squared, I can do that. I could also use sine, cosine. I could use the sine of 53. I could use the tangent. I can use a number of different things, but we're going to use this way. So 12 squared is 144 plus A squared is 19.93 squared. It's 397.201. I'm going to subtract 144. A squared equals 253.2. Now I'm going to take the square root. So this side here is 15.9. Alright? So this is an example that I know these problems are going to take a little bit of time. You have to find all of the pieces. There are so many different ways you can go about doing it. If you're comfortable with sines, cosines, and tangents, use those. You can use the Pythagorean theorem as well. Alright? Okay. One more example. Okay. Now this is another basic triangle. Here. And a right angle here. Angle theta defined here. 10 and 12. And I want to find angle theta. Okay? So now this is where we're going to use inverses instead of what we talked about yesterday, where we did the sine, the secant, and cosecant, and all that. Okay, now my angle theta here, we know that this is the adjacent line, and this is the hypotenuse. So the cosine of theta equals 10 over 12. Now, if I want to find out what theta is, there's a nice little button on my calculator that is the inverse. Okay, so I can take the inverse, okay, cosine inverse. Okay, it's usually right above. It's the second key. It's right above the cosine itself. Okay, of 10 over 12. and they'll actually give me the value of theta. This is such a nice function to have because then we can find angles of any triangle if we know the sides, as long as it's the right triangle. So if I put that in my calculator, I get theta equals 33.56 degrees. Right, make sure your calculator's in degree mode.